Okay, engineers, on this video we are going to use the formula that we just saw of the step function. Okay. Now, imagine that you have this problem. You will see this kind of problems on the homework. You have this function which is 2 from 0 from 0 to 2 is equal to 2, and then switch to minus 1 constant in t equal to 3, then it is equal to 0. Okay, so this is 1, 2, and 3. So it is 2 and then minus 1 and then it is 0. Now the composite function will be this section, and this section. Alright, now if we do the Laplace transform of this function, what we have to do is to split the integral in 3 sections. This one, and then this one. Okay? We can do that, but let's do another approach. Let's do the step functions. Let's write this function, this f of t, as a combination of step functions. Alright? Okay, now one very common is how to make this function. Now let's assume this one. This is just 1. The function f of t equal to 1. It's just constant 1, and then let's do this function equal to 2. This is 1, 2, and 3. 1, 2, and 3. Okay, now in the next function, what I'm going to write is this step function. Okay, so on this step function is going to be u of t minus 2, according to the formula. Okay, the value of a happens to be 2. So it is going to be 0, and then it's going to be 1. Okay, now check this out, engineers. What happens if we do this function minus this function? Meaning, what if we do 1 minus u of t minus 2? What will be the plot, the results of this? Okay, now, because this is 1, it is always 1. It doesn't have a problem. Now, on this section, between 0 and 2, 1 minus 0 happens to be just 1. Okay? Okay? Now, what happens if we do 1 minus 1 on this time? 1 minus 1 happens to be 0. Okay? Okay, so we obtain this plot. Okay? Now, this is not the plot I want. It is actually this one. Alright? This is 1 and this is 2. All I have to do is to multiply times 2. So if we multiply times 2, so this one becomes actually 2. Actually becomes 2. And then 2 times 0 is still 0. Okay, so with this function, I have managed to get this one. Alright? Now, what I really want is this part. Alright? So what I have to do is build another step functions of this. Okay, now, what I'm going to continue is over here. Okay, I'm going to build the 2 and the 3. I'm going to make this one 1 and 2, but I'm going to make it negative. Alright? So this is going to be u of t minus 2, but negative. Right? So instead of becoming 1, which is here, I'll make it minus 1. Alright? And minus 1 because it is minus 1. But then we have this problem. When t is equal to 3, it has to make it 0. So what I'm going to do is this. I'm going to make the plot of in 3, 1, 2, and 3. This one. 0, and then 1. So this function happens to be u of t minus 3. Alright? So what I'm going to do is this plus this, minus u of t minus 2 plus u of t minus 3. So what is the result of that? Okay, check this out, engineers. 0 and 0 is still 0 if we do the addition. If we add together zeros, and then minus 1 plus 0, minus 1, and then minus 1 here, this is minus 1, minus 1 plus 1 becomes 0. Okay? So what we have obtained is this part of the plot. Now, the function, this function, I'm going to write it like the combination of this and the combination of that. So it's going to be 2 times 1 minus u of t minus 2. So it's this part. Now it doesn't affect because here is 0, so here is 0, so we can add together. And then plus u of t minus 3, and then minus u of t minus 2. Sorry, minus 2. Okay, so the function, we can reduce this part because we have the number 2 here, and then minus 2 u of t minus 2, and then minus u of t minus 2. So this and this becomes, the function is 2 minus 3, because this and this becomes minus 3, u of t minus 2, and then plus u of t minus 3. Okay, now what we are going to do is apply the Laplace transform of f of t, which means the Laplace transform of 2, and then minus 3, the Laplace transform of u of t minus 2, plus the Laplace transform of u of t minus 3. Okay, now, because we already have the formula, so this is actually 2 over s, and then this is minus 3. The value of a happens to be 2, so it is exponential minus 2s over s, and then plus, here the value of a happens to be 3, so it's going to be the exponential minus 3s over s. And then you get the Laplace transform of this function without using the Laplace transform definition, which is the integrals. So what we have done is to build this plot using a combination of step functions, right? And this is very common on some of the problems, all right? Okay, the next video we are going to see more about the step function, but in this case we are going to see not only constant functions, but actually functions that are not constant. There are actually functions, and that is actually the translation on the t domain. See you on the next video.